All right, problem 61 off the math subject GRE practice test. We're getting back into calculations here. I think it ends up being a differential equations problem. We're told that a tank initially contains a salt solution of 3 grams of salt dissolved in 100 liters of water. Okay. And a salt solution with this concentration is sprayed into the tank at this rate. And then it's continuously mixed instantaneously, I'm told to assume. And then, so you're like, more and more water is going into the tank? No, because it's emptying out the other side. The mixture flows out of the tank at a rate of 4 liters per minute. Wait a minute, that's the rate here. Okay, so I'm not getting any extra volume. The amount that's going in is the exact same as the amount that's going out. So I'm always going to have exactly 100 liters of water in this tank. If the mixing is instantaneous, how many grams of salt are in the tank? So what I'm going to do, how many grams, often what they're asking for, it helps to, that setting your variable as that will help when you're solving this thing. So I'm going to let x represent the number of grams of salt in the tank after 100 minutes have elapsed. Okay, so what is x when t equals 100? Essentially, what it's asking you is to come up with x of t as a function and then find x of 100. Coming up with x of t as a function is hard because really all I know about is the change in x. Right? Really what I know about is the change in x over the change in time. X is the amount of salt in the tank. And I can talk about this change in the amount of salt by just looking at what's going in and what's coming out. So what's coming in is salt solution containing 0.02 grams of salt per liter. Okay. Is sprayed into the tank at a rate of 4 liters per minute. So in terms of the amount of salt, I have 0.02 times 4. I get 0.08 grams, I think it is, of salt every minute coming into this thing. But unfortunately, some salt is leaving this amount too. If x represents the amount of salt in the tank at a given time, and the water is escaping at a rate of 4 liters per minute, then the amount that's going out is 4 times whatever the concentration is. And the concentration is x over 100. X being the amount of salt in 100 liters of water. So another way to write this is 0.08 minus 0.04x. So I'm supposed to come up with a function of t, and all I know is about the rate of change of my function. Differential equations. So what I'm going to do here is I'm going to say dx dt is equal to 0.08 minus 0.04x, and I'm going to try to solve for, come up with an equation x of t, I guess is the way to think about it. And the easiest way to do this is separation of variables, or at least one way to do it. If I factor out a negative 0.04, then that will leave me with x minus 2 over here. And that will allow me to get all the x terms on the left side of the equation and all the t terms on the right side of the equation. I can say that, should have left myself more room, dx divided by x minus 2 is equal to negative 0.04 dt. And man, I wish I didn't have these dx's and dt's in there. I'm essentially treating this like a fraction, multiplying the dt over to this side of the equation. I can get rid of them by integrating. So the integral over here is the natural log of the absolute value of x minus 2. And really a plus c should be over there, but there'll be a plus c on this side, so I'll kind of subtract the unknown constant over to this side and get negative 0.04 t plus c. So I want this to be x as a function of t, so I would like to solve this for x, so I can do e to both sides of the equation. That gives me the absolute value of x minus 2 is equal to e to the negative 0.04 t plus c. The absolute value of x minus 2, well, note that this is always a positive number because x represents the number of grams of salt in this mixture. And I started out with 3 grams of salt in here. And I'm kind of diluting it because I'm only putting in 2 grams per 100 liters. But I'm never going to get below 2, right? I'm always going to be somewhere between 3 and 2. I start out with 3, that's the most I'll ever have. And then I'm diluting it, it's getting closer and closer and closer to 2. But I'm always going to be greater than 2. So what that tells me is that this is always going to be a positive number, so I can just write x minus t. Over on this side, I have these exponent rules. I have e raised up to some power plus something else, I can rewrite that as e raised up to negative 0.04t times e raised up to the c power. But e raised up to the c power, I can write as just a constant times k, or it's just a constant k. Okay, so how do I figure out what my constant k is equal to? Well, I know that initially, I know that x of 0 is equal to 3. I know that initially there's 3 grams of salt in here. So when t equals 0, x equals 3. So 3 minus 2, aka 1, has got to be equal to k times e to the 0.04 times 0. What I'm saying is that 1 has to be equal to k. So what I get is I can use this form right here and get that x of t, I guess, is equal to, if I'm going to write it in function notation, I don't want this minus 2 on this side of the equation, so let's add it over to the other side. 2 plus, and then instead of writing k, I know that k is equal to 1, so I get 2 plus e to the negative 0.04t. So if x of t equals this, then x of 100 would be equal to 2 plus e to the negative 100 times 0.04 is just 4, so I get to the negative 4 power. 2 plus e to the negative 4 looks like option E right here. We get our right answer. We're done. We're moving on. Well,